Here are some examples of 1, 1 functions. Consider this function f from the set of all natural numbers to the set of all natural numbers defined as f of x is equal to 2x. 1 goes to 2, 2 is mapped to 4, 3 goes to 6, 4 goes to 8 and so on. There is no other number x belonging to the natural number which is mapped to 2. Only 1 is mapped to 2. Similarly, only 2 is mapped to 4. But how do we prove that it's a 1, 1 function? So let us check. Consider the two natural numbers x1 and x2. So f of x1 is equal to 2x1 and f of x2 is equal to 2x2. We have seen the proof technique, right? I assume 2x1 is equal to 2x2. What do I get after cancelling the 2's? x1 is equal to x2, which means if in case 2x1 becomes equal to 2x2, then x1 is equal to x2, and hence f is always a 1, 1 function. The next example. Consider f from real numbers to real numbers defined as f of x is equal to 1 minus x. F of 0 is 1, f of 0.5 is 0.5, f of 2 is minus 1, f of 1 is 0 and so on. How do we prove this is a 1, 1 function? Let x1 and x2 be two real numbers. F of x1 is 1 minus x1 and f of x2 is 1 minus x2. I assume f of x1 is equal to f of x2 and hence 1 minus x1 is equal to 1 minus x2. Cancelling 1 on both the sides give me x1 is equal to x2, which contradicts our assumption, and hence f is 1, 1. So what do I assume every time? I assume that x1 and x2 are different, but f of x1 and f of x2 are the same, and hence I arrive at the contradiction. The last example. Consider this function from real numbers to integers defined as f of x is equal to square bracket x, which means it is the greatest integer function. What is the greatest integer function? What do I get after applying the function? It is the greatest integer less than or equal to this x. So f of 0.5 is the greatest integer which is less than 0.5 is 0, and hence I take it as 0. F of 1.239 is 1, f of 1.345 is also 1, f of 1.995 is also 1 and so on. You observe here I am getting 1 thrice. For every value between 1 and 2, I'll get it as 1. Hence, f is not 1, 1. We need not prove since we have arrived at a counter example which says that f is not 1, 1.